So Unit G for us in this course is on statistics, and statistics are a topic that are really across multiple disciplines. You've probably done some statistics in your math background, but there will be a few new things in this unit. We've got to divide it up into 4 different sections, and really, I just wanted to kind of summarize this overview of the statistical process and where the different topics that we take a look at in this unit factor in. So first off, the measures of standard or central tendency, those would be summary statistics. And so G1 is in here. We're going to do mean, median, and mode, but also standard deviation, which is probably something that's new to you. The next thing is graph basics and identifying bias. So graphing data. We're not going to make a lot of graphs, but we'll interpret some graphs, and also looking for potential bias. This is an important thing as we're consumers of statistics all the time in our lives, and it's good to be aware of how numbers can be presented in a way to make you believe one thing or another. So it's good to have a little bit of literacy on that. And the next thing would be normal distribution and Z-score, solving problems. So in that one, we're also in here for G3. So this is like a standard bell curve. We won't really talk about percentiles so much, but that idea of a normal distribution or a bell curve, something you've probably heard about before. The last one is, reporting out on data or statistics often involves a measure of confidence and a margin of error. And so this will always be assumed, but we're going to be talking about the margin of error and how that can build our confidence intervals. So statistics is a branch of applied mathematics. It's all about data and number crunching on the data. So these measures of central tendency sort of measures how the numbers are laid out. So mean, median, and mode, you may have covered in another math course. This is the average. It's in our materials represented by the variable mu. It looks like kind of a written or a scripty or cursive u, lowercase u, but it is a Greek letter and it's pronounced mu. We're not going to be dealing with that one so much, and really because their average is calculated in the same way. You add up the total of all the data values and divide by the number of data values. So we'll practice that on the next page. The median is the middle number. And so for the middle number, you have to arrange the data from smallest to biggest or biggest to smallest and figure out which number is in the middle of the data. If there's an even number of values, then you're going to take the two middle and average them. So average two middle data values if needed. Mode is the most common number. Oops, not, I was just going to write it again. Most common number. And it's important to know that there could be multiple modes or no modes. And so we'll practice these on the next pages. So again, these are something that you've probably done before. If we have 6 students writing a math test and they all got these grades, what was the average grade in the class? So the mean. What was the median mark? And what was the mode of the data? So I find the easiest way to do this is to start by arranging them from biggest to smallest. So we could go 73, 73, 76, 78, hopefully I'm not missing one, 89, and 98. And in this way, I can figure out which number lies in the middle. And so this also makes it easier to total those ones up. So the mean is the sum of all those numbers, and I just leave them in the order that they're written out. Keeps me from copying wrong, and also makes me look at the data more than once to catch a potential error. So the mean is the average. I total all those up and divide by 6 because that's how many students there were. That gives me on my calculator 487 divided by 6, and I don't always show my work. I usually just leave it in the calculator. When you add these up, be sure to hit equals at the end and then divide by 6, otherwise you're going to get a weird value. And this should work out to 81 as an average grade in the course. So, or on the test or whatever it is. So the median mark would be that middle mark. And so this set of data being an even number, there isn't a middle number. And so for this one, we're going to have to take the average of the two middle numbers. So 76 plus 78 divided by 2 would give me a median mark of 77. And the mode, when I've already arranged them from smallest to biggest, I can see that the most common score was 73. You may have done these before. The next one I go about in the same way. I arrange from smallest to biggest. You don't have to do it this way, but it is the way I do it. Whoops, 3.4, 3.8, 5.7, 7.8, and 9.2. So in this one, I start with the mean. I add all those up. I did it on the calculator because they're already written out here. And then I divide by 6. On my calculator, I got a mean of 5.25. This one says round to 2 decimals. Now that I have them here all lined out, this is allowing me to calculate the median, the middle mark. And like the last question, I have an even number of data. I have 1, 2, 3 here and 1, 2, 3 here. So I'm going to have to calculate the average of those middle 2 marks, or whatever they are, data. So I'd have 3.8 plus the 5.7 and divide that by 2. Remember, when you're doing this, always hit equals before you divide by 2 or you'll get weird numbers. And that gives me a median of this data at 4.75. The mode for this one, if I take a look at the frequencies of these, there is no mode. And that's fine. That's the way some data are. So oftentimes data is arranged into tables. This can make understanding elements a little easier, but can complicate some others. So this could be the data set that is represented. We have the number of students assigning this rating to their teacher. We have a total of 12 students. And so for this one, I find it's much easier to calculate the mode first. We can see the most common score is 3. 5 students gave the score of 3, so that's the mode of the data. The median is also a lot easier to see from this. So if we see where the middle score would be, well, there's a big group in this 5 here. So we'd have 1, 2, 3 above, there's 4 below. The middle number is going to be somewhere in this group of the 3 ratings. And so that's also the median. The mean for this is a little bit trickier to calculate. I'd have 1 student giving the score of 1. I'd have 2 students giving the score of 2. I have, oops, sorry. I did that backwards. I have 5 students assigning the score of 3. I have, it was right what I wrote down, but in my head I was doing it differently. I have 3 students giving the score of 4, and I have 1 student giving the score of 5. I'm going to divide that by that total number of students. That's why I calculated that over there on the table as one of the first things. The questions might not tell you to do that, so it's a little bit sneaky that you have to be able to see that in the data set. So on my calculator, if I do this, I use brackets on mine, or you can even just mentally, multiply these and then add them up. However you get there, check that your calculator works. I end up with an average or a mean value also of 3 for this data. So sometimes the mean, median, and mode can be the exact same number, but sometimes they can be quite different. The last 2 that we have here, and then I'll do a separate video for standard deviation. Again, this is in a chart. Take a look at it. I'm going to throw my answers up. I'm not going to talk all the way through it. It's a lot like the last one. And when I see them in a chart, I find it easier to look at the mode, the median, and then do the mean or the average. So if the mode for this, the most common, however many numbers of days, that would be a 5-kilometer run is the most common run for this set of data. The median, the middle number, would also be 5 kilometers. You have 17 at 5 kilometers, and you only have 14 greater than that 5 kilometers, so that middle number is going to lie in that big group of fives. The mean, again, it's 17 days times the 5, and 10 days times the 10 kilometers, and 4 days running 20 kilometers divided by the total number of days that she ran. And so the average to 1 decimal, it tells me that, is 8.5 kilometers. Last one. This one is represented in a graph format or a histogram. There's more of that in the next section. We could make a frequency table for this. So number of goals and frequency, or how many games got that many goals. So we had 2 goals in some games, 3 goals in others, 4 games in some, and also 5. And the frequency, reading it off the chart, there were 3 games that scored 3 points. There were 6 games that, 3 goes in 2 points, sorry, I was reading it wrong. 6 games scored 3. 4 games were 4 goals, and 5 goals were scored in only 1 game. And so this would be that frequency table. It's a summary. The total number of games would be 14 games total. So whether you read the numbers for the mode, median, and mean off of this, it doesn't even ask me that. It just asked me to calculate the average. Well, that's easy. So the mean of this, the average would be 3 games got 2 goals, 6 games got 3 goals, 4 games scored 4 goals, and 1 game, they scored 5 goals. So that's out of a total of 14 games. So that's the number of points scored in those, the total of the games. And that works out to 3.2 goals per game. Or the average number of goals. So the last measure of central tendency is standard deviation, which is something that's probably a bit new for you. So I've made that into a separate video.